Good morning, everyone. I am Bhavanesh Sharma, Electrical Department. Today we have discussing about an induction motor. Content introduction, why use the induction motor, classification of motor, types of induction motor, working principle of induction motor, rotating magnetic field, and induction motor speed. Introduction. Three-phase induction motors are the most common and frequently encountered machine in industry. Reason: simple design, rugged, low price, easy maintenance, and wide range of power rating. Frictional horsepower about 2 to 10 megawatt. Run essentially as constant speed from no load to full load. Its speed depends on the frequency of the power source. Not easy to variable speed control. Required a variable frequency power electronic drive for optimal speed control. Why use an induction motor? Robust, no brushes, no contact on rotor shaft, high power weight ratio compared to a DC motor, low cost power, easy to manufacture, almost maintenance free except of bearing and other mechanical parts. Classification of motor. Motor classified into AC motor and DC motor. AC motor again classified into two parts: synchronous motor and induction motor. Induction motor also called as a asynchronous motor. Induction motor again classified into single phase and three phase induction motor. Single phase and three phase induction motor discussing in our next slide. Again, the DC motor classified into separately excited and self excited. Separately excited, self excited again classified into three parts: series, compound, and shunt. Compound motor again classified into two parts: long shunt and short compound. Types of induction motor. The types of induction motor can be classified depend on the whether they are a single phase or a three phase induction motor. Single phase induction motor are classified into split phase induction motor, capacitor start induction motor, capacitor start capacitor run induction motor, shaded pole induction motor. Three phase induction motor are classified squirrel cage induction motor and slip ring induction motor. Three phase induction motor. Like any other type of electrical motor, induction motor, a three phase induction motor is constructed from two main parts, mainly known as a rotor and stator. Basically, stator is a constant part and rotor is a rotating part. Stator, it is the name indicating stator is a stationary part of induction motor. A stator winding is placed in a stator of induction motor and the three phase supply is given to it. Rotor, the rotor is a rotating part of induction motor. The rotor is connected to the mechanical load through the shaft. Working principle of three phase induction motor. Basically, the working of three phase induction motor just like same as a transformer working. We have discussing the stator of three phase induction motor consists of overlapping winding offset by an electrical angle of 120 degree. When we connect the primary winding or the stator to a three-phase AC source, it establishes rotating magnetic field which rotate at the synchronous speed according to Faraday law, and EMF induced in any circuit is due to the rate of change of magnetic flux linkage through the circuit. As the rotor winding is an induction motor are either closed through an external resistance or directly shorted by the end ring. and cut the stator rotating magnetic field, and EMF is induced in a rotor copper bar, and due to this EMF a current flow through the rotor conductors. Here the relative speed between the rotating flux and static rotor conductor is caused as current generation. Hence, as per the Lenz law, the rotor will rotate in the same direction to reduce the causes. It means the relative velocity, thus the working principle of three-phase induction motor. It may be observed that a rotor speed should not reach the synchronous speed produced by stator. Why single phase induction motor is not a self-starting? We know that this three-phase induction motor is always a self-starting, but single phase induction motor not a self-starting. Reason: single phase induction motor has distributed stator winding, and a squirrel cage induction motor, squirrel cage rotor, when feed from a single phase supply, its stator winding produce a flux which one alternating, it means one which alternating along one space axis only. It is only a synchronously revolving or rotating flux in, as in the case of a two or the three phase of stator winding feed from a three phase supply. Now an alternating or pulsating flux acting on a stationary squirrel cage induction motor cannot produce rotation. Only a revolving flux can produce rotation. That is a way why a single phase motor is not self-starting. Rotating magnetic field. Balance three phase winding, it means mechanically displaced 120-degree angle from each other but same magnitude, feed by balanced three phase source. A rotating magnetic field with a constant magnitude, it produces rotating with a speed. The formula is that the n synchronous equal to 120 f upon p, where f is the frequency, p is the number of poles, and synchronous speed in rpm. Synchronous speed are depend on number of poles used in and frequency. If we have used two number of poles at 50 Hz frequency, then the speed is 3000 rpm, but two pole at 60 Hz, the speed is 3600. We use four pole, then speed is 1500 and 1800. That's depend on frequency and speed. The synchronous speed is directly proportional to the frequency and inversely proportional to the number of poles. We have increasing the number of poles, then the speed of synchronous speed is always decrease, and the we have increasing the frequency, then the speed of synchronous machine is always increase. Slip S equal to n synchronous speed minus rotor speed with respect to synchronous speed, where S is denoted by slip. Notice that the rotor run at a synchronous speed, then slip is 0. If rotor is a stationary, then slip is 1. Slip may be expressed as a percentage by multiplying the above equation by 100. Notice that the slip is a ratio and does not have any unit. Slip is unitless. Induction motor speed. So the induction motor will always run at the speed lower than the synchronous speed. The difference between the motor speed and synchronous speed is called the slip. And slip equal to n synchronous minus n motor, where n slip is the slip speed and synchronous the speed of the magnetic field, or nm mechanical shaft speed at the motor. Thank you.